go. All right, guys, so what we're doing today is we're finishing up chapter 1.2, our transformations and these parent functions. Now, we went over this yesterday. We kind of have these four basic parent functions. We have a constant function, and constant function is just going to be a number. So like 1, 2, 7. It's just a number, and it would be a straight line. Now, the domain for this is all real numbers. Well, the domain for any of these parent functions is all real numbers. And the domain for any of the transformations we are going to look at will be all real numbers also. So the domain really doesn't change. The domain is going to be all real numbers. The domain is the values of x which we can plug into the function. Now, our range changes a little bit for each one. Now, the range for a constant function is just whatever that number is. Since f of x equals 1, our range is 1. Now, the domain for a linear function is all real numbers. The range is all real numbers. It's a straight line kind of going up or down. It will never be straight across because that would be a constant function. Our absolute values, the way we really can recognize an absolute value is the V shape. All right, guys, Chromebooks away. Is a V shape because the absolute value function will be a V shape. It's either going to go up, both sides going up, or both sides going down. So it's easier to identify that because it is a V shape. Now the domain for it, as I said already, is all real numbers. And for the absolute value, without any transformation, is saying that y, the range is going to be greater than or equal to 0. Now for most transformations, when we talk about these here, the only way the range is going to change, well, never going to change from all real numbers, but for these two here, is if it's moved up or down, or is a reflection. If we have a transformation moving it up, a vertical translation up or down, or a reflection is the only way that the range will change for these functions here. And our last type is a quadratic. A quadratic is all real numbers where y is greater than or equal to 0 for the range, and all real numbers for the domain. Now we had some basic types. So our linear, we define it as y is equal to a. Oh, here, I'm going to make it a little bit different. X minus h plus k. Our quadratic was y is equal to a times x minus h squared plus k. And our absolute value function was a is equal to, not a, y is equal to a times the absolute value of x minus h plus k. And we went over these some yesterday, and again, we'll go over them again today, what the values mean. So linear. So we have these three here. Now, the first thing we talked about was a horizontal. Now, we didn't specifically call it horizontal translation. But a horizontal translation moves the function either to the left or right. A horizontal translation moves it either to the left or to the right. And it's our value of h. Horizontal translation is the h value. And what did we learn about this yesterday? It kind of lies to us, doesn't it? Because if inside the parentheses we have h or x minus 2, so if we have inside here x minus 2, what is it moving? It's moving 2 units to which direction? Left or right? It's moving to the right. Yes, because minus 2, it's not moving it to the left, it's moving it to the right. Now, if it was plus 2, then it would be to the left. Because again, our basic function with inside parentheses, it is always minus h, minus h, minus h. So when we have minus 2, the actual value for h is positive 2. So it's moving to the right. Now, when it is positive inside the parentheses, it's really the same as saying x minus negative 2, because a negative and a negative make a positive, so it moves to the left. So what's inside parentheses is kind of a little misleading, or inside the absolute value is a little misleading. So horizontal translation moves us left or right. It's the value of h. Our other one we had was vertical translations. Vertical is moving it what? Up or down. And that value is what? K. Now, when it moves it up and down, it is not lying to us. Unlike horizontal, because it's our value of K. It's outside the parentheses. So if we had something like y equals x plus 2, it's moving it up 2 because plus 2. If it was minus 2 instead of plus 2, it would be moving it down 2. Yes? And that's it. So vertical translations are not too bad. Anybody remember what another one we went over? Reflections, yes. And as I said earlier, this vertical translation will change what the range is. So if we just had a horizontal left and right, the ranges of the parent are going to be the same as the transformation. It's not changing it. When we move it up or down, that's when we're changing it. We're changing what values of y show up. Now the reflections came in two parts, negative a and negative x, because we had one of each. If we have negative a value, it is reflected across what? The x-axis. If x is negative, it's reflected across the y-axis. So how this is going to show up, we'd have y equals negative x plus 2 squared. This is going to be across the x. Because when it's outside, it's connected to the a value, it's across the x. Now, when it's x is negative, we're looking at something like y equals something like this here. It's with the x. It's inside those parentheses. Y'all see this here? Yes? This here doesn't show a whole lot of change for the absolute value or the quadratic because it doesn't change it too much. It doesn't change it too much. So looking at that note sheet on the first page, do y'all see where it says the quadratic function up there at the very top? Yes? So this is probably going back several years, probably middle school. In art class, when they gave you a sheet of paper and the first thing they told you to fold it was hot dog style, yes? Made a nice solid crease, open it back up. Then they gave you a bunch of paint. So you folded it here, and they told you, don't paint on this side. Paint something pretty over here. Yes? So you made a picture. So we did something here. And once you got finished painting it, they told you to fold it back. Yes? And when you open it back up, what happened? What you had on one side got transferred to the other. So it looked really cool. That is essentially what a reflection is if we did the same thing, we reflected across that line. When you open it back up, the reflected image would be what's there. Does that make sense? So if you look at this here, with these absolute value and the quadratic, if I folded it along that line going up and down, would it end up back onto itself? It mirrors it right there, doesn't it? That's why this reflection with just the basic parent function, like this here, doesn't show anything. Because it's right where it's supposed to, it ends up going on top of itself. It just flips it. It's also why if you stare at a mirror, it's hard to tell if going from left from right. At least it is for me. Because they both look the same for the most part. That's the same thing, because the mirror image is the exact same. Does that make sense? It's not until we move it a little off center that we start seeing the difference for those two. So reflections. If A is negative, it's in the y across the x. If x is negative, it's across the y. Now we had one last one that we talked about. Vertical what? stretch slash shrink. If go on and add the absolute values in your reference, because I think that might help. Because when the absolute value of A, because on the notes yesterday what I wrote down, I just said A. I didn't say the absolute values. So if you're able to keep that straight, that we're not looking at A, if it's positive or negative, we just want the value of A. If the value of A is greater than 1, then it's a stretch. If the value of A is less than 1, but greater than 0, between 0 and 1, then it's a shrink. So -2, if I said A was -2, what is the negative part? Negative is dealing with not stretch or shrink, it's part of the reflections. Yes? This is why the textbook goes with this way here. Because we more care about the 2, not the negative with shrink or stretch. If it's stretch or shrink, we just want the value of A. We don't care about the sign. Sign doesn't matter. Because if it's negative, it's a reflection. Negative is part of the reflection. It's not a part of the stretch or shrink. Can y'all see that there? So textbooks put it as the absolute value of A. Just in case A is a negative number, it doesn't matter. We don't care about the negative. We care about the value of A. What number is it? And these are our different ones. There's only one other one that we have, and it's horizontal stretch and shrink. We'll get more into that when we start talking about absolute values and quadratics. It's essentially the same thing, but it shows up inside the parentheses. A horizontal shrink is a value of in there that's between 0 and 1. And so when we apply it, it's 1 over that number. Did anybody just get lost? Yeah, it's confusing. It's a little bit confusing. We're not going to touch it because I've never seen it show up in college algebra or anything higher. More than this is what it is, we're moving on. Okay? And that's what we're doing. Now, what we're doing today is talking about these here. Talking about these functions. We're not having to create them. We're not having to change them. We're wanting to identify them. So there's 3 main things we want to identify. Domain and range of the parent and the new function. And what happened? How did it change? So looking at this here, Stormy, what is its parent's function? Absolute value. Because it looks like it, doesn't it? It looks like an absolute value. It has a V shape. So its parent function is the absolute value. Absolute value function. What's the domain of the absolute value function? Anybody can answer. What is it? Domain of the parent function. Domain of this absolute value function is, well, on page 1, what does it say for absolute value? Domain. All real numbers. What does it say for all of those? All real numbers. Because the only way that we can get a domain, an x value that is not all real numbers, causes us to divide by 0 or something that doesn't work. Y'all remember taking square roots? Yes? Can we take the square root of a negative number? Can I take the square root of -4? You probably tried plugging it into one of those calculators and it says domain error, yes? That would be a case where it's not all real numbers, where we have something like that, or we're dividing by 0. But these we don't have. So the domain is all real numbers. I'm going to draw the all real number symbol. But it's all real numbers. So you can write it out or draw that. It's hard if you don't remember that's all real numbers, just write all real numbers. Because that's the domain. What is the range? It's right there on page 1. Right underneath it, it says what? Y is greater than or equal to 0. The new one. So the domain, I'm going to go on and write it in because we know the domain for an absolute value function is all real numbers, yes? my very poorly drawn D. So the range. So we're looking at the y values. So because it's an absolute value, all the values of y are not covered. Because as we can see with the graph, are we using anything below 0? Is this function have a y value of anything less than 1? What is it? It's all values 1 and greater. So what would we say? Y is than or equal to 1. And that's all we have to say for domain and range. Now on the homework, it's going to have you fill this stuff in. It will have little boxes you drag and drop. Now the other thing it's going to ask is it's going to ask about the transformation. How it changed from the absolute value of x to this here. So there's two things that are different. What is one of them? It's one of these two here, isn't it? What is the 2 telling me? We have what? A. Because 2 matches up to what on this here? Matches up to the A, doesn't it? If I have an A value of 2, A matches up with the what? It's not horizontal or vertical translation. It's a vertical what? Stretch or shrink. And how can we tell if it's a stretch? If the value of A is greater than 1. Is it greater than 1? So we know that this is a vertical stretch by a factor of 2. Because we're increasing every value by a factor of 2. It's increasing faster. Now what was the other part? Well, we had what? Plus. What does the plus 1 tell me? It's moving everything, what? Up 1. And up 1. And they'll call it unit. Up 1 unit. That's it. That is all we have for this here. So the domain of our parent was all real numbers, y greater than or equal to 0. Well, what did we say about the translation? We moved it up 1, yes? The range was what? Y is greater than or equal to 0. Now what is it? Y is greater than or equal to? What did it change? It went up. So the up and down translation will move the range up or down. What do we say about reflection in the x? It makes it go flip, doesn't it? So what's it going to do here? The range is going to flip. Because if we flip it across the x, it's not going to be greater than 1. It would be less than. Oh, put that down. Here we go. We're going to do another one here. So this one here, what is its parent function? Its parent function is it's linear, isn't it? Linear. The domain is all real numbers. The range is all real numbers. This is the one exception. For the rest of them, the quadratic and the absolute value ones, because this one here, the range and domain are going to be all real numbers no matter what we deal with. So the new one is actually going to be, the domain is all real numbers and the range. Because it's a straight line and we see that it's going up and down indefinitely, the new one, the domain is going to be all real numbers. The range is going to be all real numbers. So that's kind of easy. That's nice. That one's simple. The domain and range will be all real numbers for the parent and the new one, this one here. So what we really need to look at is the transformations. So let's start with the -3. There's 2 parts to it. Do we want to talk about the negative or the 3 first? Doesn't matter which. So the negative tells me we have a what? A reflection. Because when we have a negative outside the parentheses, it's a reflection across the x-axis. Because the negative tells me that we have a reflection across the x-axis. Because when A is negative, it's a reflection across the x-axis. Now the 3 is talking about a vertical what? Because it's going to be stretch or shrink. Because it's a stretch if A is greater than 1. It's a shrink if A is, so if 0 is less than A is less than 1. It's between 0 and 1, it's a shrink. If it's greater than 1, it's a stretch. It's a stretch. Even though it's negative 3, we don't care about the negative. We just care about the 3. So this is a vertical stretch by a factor of 3. Now we have one last thing. We have that minus, or x minus 2. Now we didn't have this yesterday, but inside parentheses, inside absolute values left and right. It's just going to be, that's what it is. I don't normally see this show up too often with a linear function, because we can multiply it through by negative 3 and just treat it like we did the other day. But that negative 2, or minus 2, tells me it does what? It moves to the left or right. It's going to move what? How far? It's going to move right too. And that's it. Questions on this here? We kind of feel good with this here so far? Yes? I want to look at this one more. We're going to look at one more of these here. And then we're going to move on to the next type. So what kind of function does this belong to? What is its parent function? Quadratic. Okay, quadratic. And the reason we know it's a quadratic is because of the U shape. All quadratics will have a U shape to them. Now the domain of the quadratic is the range. Is? Y is? Well, the new one, the domain, is all real numbers. That's our range. If you find it hard to see what the range is, did we have a vertical translation up or down? Do we see anything in that equation that would imply a vertical translation? No, because vertical translation is something being added to the end, isn't it? We don't have that. Do we have a reflection across the x or the y? The reflection across the x would be the a is negative. Correct. The reflection across the y would mean the x is negative. Do we have either one of those? So is anything happening to the range? No, so that's going to be ISO greater than or equal to 0. So if you're sometimes having trouble seeing that, check those. Did the function move up or down? If it didn't, that doesn't change. If it's not a reflection, you can just find a seat. If it doesn't have a reflection in either way, it's not going to change. It's not going to change it. Okay? So let's talk about the transformation. So what do we have? Well, and I just covered it up. So we have a 1/4 and we have the -3. Well, the 1/4 tells me I have a what? A vertical shrink of 1/4. And the -3 tells it it moves 3 units. What? 3 units right. That's it. And a lot of what the homework is not writing this all out. It would be like, so there's a vertical blank of 1/4. Because it's 1/4 its shrink. So you're just putting those individual words or numbers in. You're not having to fill this whole thing out. Okay? So we good with this here so far? Okay. Now this is the other type. Now you're not going to have to actually graph anything. It's not going to make you actually graph. It's going to give you 4 graphs, and you have to pick which one's the correct one. Now looking at this here, the graph is x minus 4. So what is the parent function? What is its type? Is it constant, linear, quadratic, or absolute? This would be a what? This parent function. It'd be linear, wouldn't it? Because we don't have exponents, we don't have absolute values. This is a linear function. It's an equation of a line. Now the equation of a line of our basic linear function, as we had on the other page, goes to the origin is just 1 by 1. Something like this here, yes? We've seen a linear function, just a basic y equals x, time and time again. Yes? You all can graph y equals x? Or at least you have the picture of y equals x? Now before we graph the new one, because normally if we graph the new one, we pick a few points and plot those, yes? The y-intercept, then 0, we can plug in 0 for x, and then 1 for x, and do a table, and then plot those points, yes? Y'all remember doing that in Algebra 1? That was not fun? Okay, before we do that, let's talk about the transformation. What happened to this here? Well, we have the minus 4. So what did it do from its parent function? It went down 4, yes? So that means every point on this line did what? Went down. So instead of being at 10, 10, it's at 10. Instead of at 0, 0, it's at 0, negative 4. And that's why we're doing this. That's why we're going over this. Is because now having an idea of what the transformation are and how they work, you can now have a mental image and understanding of what the function is going to do, or what we can expect it to do. So when we start solving it, we have an idea of what we're looking for. But that's it. That's all we have to do for this here. Questions on this here? Now this here, I will go on and tell you is an absolute value. Hopefully it was kind of a giveaway. It had the absolute value bars, yes? Now before we graph it, let's describe the transformation. Well, what's happening? Plus 1 inside. Would not be up, it's going to the that means every point along this should shift 1 unit to the left. And that's it. So you just have to pick one of the 4, the one that actually had the parent function and the one shifted 1 to the left. And then I think it has some descriptions about domain range, but that's it. Questions on this here? Are we kind of getting this? Josh? How are you doing, Josh? You good? Reflections are the same thing. It's just a flip. Kind of like what I talked about with the painting. So this here is x squared. Well, x squared is going to look something like this here. And so since this here is negative x squared, it's a reflection. Across the x-axis, because it's outside the negative, is outside the parentheses, it's not inside. It's across the x-axis. So that means every point here is going to be flipped straight down. Whatever the line is of reflection, so this line here, the distance away from it will be the same. So it'll actually look something like this here. Now we actually have a decent bit of time left, and I could do, well, we've got at least 10 minutes left. We could do some more of these, but what I want you to do is go on and get started on this assignment so that you can try a few of these with me actually standing here. So if you do get stuck, I can go over them with you. Okay? Yeah. If you want to, where's your Chromebook? Yeah. I'll just hang out then because it's going to take more time for you to get there and get back than we have. Yes, I'll be there in a second. Got a question?
No, I wasn't here yesterday, so I didn't have any notes.
Okay, so just what, pretty much when we went over those first thing, writing in the horizontal translations and whatnot, that was it?
Yeah, I took some notes.
Okay. Did those make sense?
Yeah.
Okay. Yeah, no, if it ends up being that way, I just forgot. Just ask. I got another copy of them. Oh, yeah. It should be, I think, 7.9. So unless you line it up right there at the start of the dot. Okay? Yeah, so if we do the same thing here, we line this right on the inside of that dot. It's sitting right at about 4.95. Yeah, it's on the inside of that dot. You knew this from yesterday? I mean, no, you knew this. The elements of the set of whole numbers that are less than 10. Almost. What is, so natural numbers was 1 and above, yes? What did whole numbers add? 0. Yeah, so that'd be the only difference. So, yep. Yep. I can tell you right now, that ain't it.